Fundamental theorem of algebra. A decent math major at a top-notch school will learn to do this in their junior or senior year to prove it. But we can use it, and we do. Okay. Any polynomial is a product of linear and irreducible quadratic factors. In other words, every polynomial, well, I can't say every polynomial can be factored. I mean, I'm not saying we can factor any polynomial. That doesn't mean it's not a product of factors, it just means we can't find it. Okay? If a polynomial has over degree 5, meaning it has an x to the 5th, x to the 4th, sum of multiples of x to the 5th down through x. Okay? There are polynomials of that degree that can't be solved. And that's a really big, much tougher result than the fundamental theorem of algebra. But that's proved by something called Galois theory. And you don't necessarily need to know that. Just, we're going to do some things with factoring polynomials, but we're not going to do a lot because usually you can't factor the blame things anyway. Okay? So, we're going to use a factor that it can be factored. We already have. Okay. See what I mean? Now, to clarify what this means, linear, irreducible quadratic factors. Okay? Examples are x minus 5, x plus 7, x minus the square root of 9, that's not, square root of 11, or 5x minus pi, etc. Just some multiple of x plus a number. And if the number you're adding is negative, then it's a minus, right? Okay? And the form is a familiar form of a linear equation, which is y equals mx plus b. The form is just mx plus b. Okay? If you graphed it, y equals mx plus b would have slope m, y-intercept b, and I assume you know that. We'll spend a little time reviewing that idea, but that's very basic, starting from pre-algebra. Okay? Okay, and we'll probably cover it in the MCR, just to make sure. But, that's early algebra. Okay. Quadratic factors. Form ax squared plus bx plus c, or b squared minus 4ac is negative. Okay? What happens if that thing is negative? Well, if you set this thing equal to 0, you're not going to get a real solution because you're going to have a square root of a negative. Yeah, this is what goes under the square root in the quadratic formula, which I assume everybody recognizes instantly. Since you just had a test or about to have a test, we might need to know that. Okay? So, we'll talk about why that's irreducible, but it's fairly straightforward, but that's what they are. Okay? So, examples. Okay? That's a linear factor times an irreducible quadratic factor. Okay? And of course, I've already given you products. Yeah, for this time, I gave you products of linear and quadratic factors to multiply, right? Now, they might not have been irreducible quadratic factors, but they were quadratic. So you know how to multiply these using the distributive law. Okay? And I'm not going to do this one, I'm going to do another one. Okay? Expanded. Expanding this polynomial, we get x squared times x squared minus x plus 5 plus x times x squared minus x plus 5 plus 4 times x squared minus x plus 5, which equals x to the 4th minus x cubed plus 5x plus x cubed minus x squared plus 5x. That should have been 5x squared. For that. Minus 4x plus 20, and you know what I'm doing, and I don't really have to read it to you. Okay, everybody knows how to do this because I asked you to do this very early in the course, and then I asked you to do it again for today. And if you don't know how to do it, go back, look at some of the MCRs, go to Khan Academy, go to mentors. Yeah, get some mentoring if you need it. Okay? And then we say that's x to the 4th. On x cubes, we have a negative x cubed, positive x cubed, which adds up to 0. And we have no other x cubed, so just coincidentally, the x cubes add up to 0 except no. Yeah. Okay, negative x cubed and an x cubed. Okay? So I'll kind of underline these when I remove them from the expression. X squareds, we're going to have about 3 of them, I think. You have 5 of them here. You have minus 1 of them here, so you got 4 of them. And you have 4 of them, so it gives you 8. So you got 8 x cubed. Okay? And then on x's, you have 5 of them and minus 4 of them, giving you an x. Wait a minute. Whoa, stop. It's x squared. You don't have any x cubes. Okay. Again, 5 x's and minus 4 x's give you 1x. And 20. Okay? Now, what if I wrote this down in my devious meditation on what to give you for homework? And all I gave you was this and asked you to figure this out. Would you be able to do it? I wouldn't be able to do it. Okay? You can't factor because these are both irreducible. The discriminant is negative in both cases, meaning you have irrational factors, meaning I'd never find the right irrational numbers. Now you don't necessarily know what I mean by that, but you would. Okay? So polynomials can look like this, or they can look like this. Which form is nicer? This one. Okay? Because you can determine things like, for example, I know that this polynomial can't possibly be 0, don't I? Because the discriminants on both of these are negative. If I set this one equal to 0, I'm not going to get any solutions. And if I set this one equal to 0, I'm not going to get any solutions. So this one can't ever be 0, and this one can't ever be 0. So when I multiply them, it can't ever be 0. Okay? And that tells me that I'm most likely not going to be able to factor. Okay? I might look out and find the quadratic factors, but that would take a lot of trial and error. It would actually be feasible. If I throw another one in, and especially if the coefficients aren't nice small numbers, you're not going to get it. Okay? Okay. And actually, yes, I could factor that one. Just using simultaneous equations. We haven't done that yet. Okay, so anyhow, you understand my main point here. You take any product of linear factors and irreducible quadratic factors, and that represents the factored form of a polynomial. Okay? And any polynomial can be represented by that, although the factors might not have nice integer coefficients. The factor might be square root of 792. Okay? It might be square root of pi, which is even better. Okay? Might be just about anything. Okay. Well, anyhow, that's what polynomials are. Now, if you have the polynomial in factored form, you can easily find its zeros. We did that last time, right? And basically, every linear factor is going to give you a 0. Irreducible quadratic factors don't give you zeros. So if you have it in factored form, you can easily see where the graph passes through the x-axis, right? And we did some of that last time. We looked at what some of the shapes might possibly look like. Okay? So, that's kind of important. So anyhow, there's that much of it. Now there's this thing called the intermediate value theorem, which can be helpful if we're looking for zeros and trying to factor a polynomial. I'm going to talk about that a little.